Hello everyone, me S. Malarvizhi and the team who are going to present the project which we have done funded by ANRF, the assistive AI-enabled assistive wearable device which can detect the stress and fall monitoring of senior citizen. The motivation behind this project is the the Longitudinal Aging Society of India has conducted a national survey, and this reports reveals that 12% of population comprising elder people, and this projection leads to grow by 319 millions by 2050. So the technology challenges faced by the elders is that the serious mental health conditions, raising disability, inadequate geriatric infrastructure, as well as the urban and rural divide in accessing the medical services, digital divide, the inhibition or barrier to use the devices. So again, when you take the fall of the elder people is a concern, and this will be increasing from 14% to 53%. Again, this is a LASI reports tells this, and this is particularly for the people who are above 60 experience repeated falls. So motivated behind the facts and the cost involved in medical spending and the rehabilitation and the percentage of the stress reported in the Indian scenario, we proceeded to develop a wearable sensor incorporated AI device. So the definition of problem states that we want to make it as an wrist-wound wearable device. We analyze the signal which is coming out from the sensor to understand the stress and the activity monitoring. And we will provide a mobile app and web app for the next care of services. The objectives are listed below as this is stated in the ANRF project proposal. The flowchart defines the choice of the microcontroller, the hardware schematics which we have developed through Altium board, Altium designer software, the fabrication of the components, and the signal acquisition is the next stage which enable us to do the data set creation. And when you see the aging population and the fall of aged people is so far not reported for Indian context, as well as the stress of the elder people who are lives independently, which is also not reported. So this project aimed to acquire the signals and provide the data set collection, which will be open up for public. And we develop a machine learning model and web app for this end user. So pre and fall detection. We define the pre-fall is a fall is not an intentional movement which happens incidentally, and for elder people if it happens the cost is heavy. So we have to make a understanding of pre-fall condition, detect it so that we'll make a suitable safety and preventive mechanism. This is an experimental setup which we have done it in the at SRM. So we take the signal vector magnitude of acceleration and the gyroscope. We define it the fall as a peak of the signal which is being detected, and the time this lapse before the fall is we define it as a pre-fall, and it normally is uh, 2 seconds. And the methodology we used a customized method of threshold based detection based on time domain, frequency domain, and using kinematic analysis. And we understand we use early warning when we detect the pre-fall, and the fall alarm also continuous fall alarm also we created. We have done it using the Python libraries. So this is a sample of the signal which we have occurred for forward, backward, and lateral falls. So the one which is indicated here in this red color is a fall event, and the yellow color is a pre-fall event. So we want to devise a device which can understand this pre-fall timing and give an alert. So this is a novelty which we want to keep it forward, as well as the signal acquisition for the stress understanding is the heart rate and interbeat interval. And this is a sample of the signal which we have acquired through the PPG signal. And the PPG is a photoplethysmoscopy, and the EDA is a signal which the dermal activity based on the skin temperature, the conductivity of the signal gets changed. So that is also a variant which we pick up to understand the stress of a person. So this depicts the flowchart of signal processing which we have undertook. It's an empirical mode decomposition which we have done, and we have further processed using Hilbert transform. So this it gives an idea of what is our design and how we made an exclosure. And this is schematic diagram, and through which we have collected the data for the stress of an elder people as well as the fall detection data sets of elder people. And this is a signal processing one for an ML detection, for labeling as well as the feature selection. So this tells about the signal labeling which we have described in our paper in IEEE Sensor Journal. This is an experimental procedure which we have taken. We have done some natural video we asked them to do, which is a baseline, and self-reports, and as well as the stress phase we have given for scoop test and interview questions. This we have used a pilot study for elder people. And this is an architectural diagram of ML using the data which we have acquired through the bidirectional LSDM model which we have put forth. These are all the statistics of the results which you have got. And this is a web app that we have developed. And this is an ML model which we have wanted to identify the activity in daily life, fall detection and pre-fall detection. So based on which we are intended to develop a web-based application which can detect, when they wear it, we can detect the stress as well as the fall detection, which is a real-time one. And the future scope, we want to reduce the size of the electronics which we have developed, and as well as we want to do the pneumatic airbag protection for the fall, the safety of the fall. Thank you. In our description, we have given out all our publications. Thank you very much.